I'm going to talk about one of the most exciting things changing in the world of technology today, which is GenAI, as well as the predecessor, traditional AI. And when people talk about that, there's really a couple things. One is everyone's talking about large language models. In the keynote this morning, somebody said, who is like experimenting, playing with it. Almost everyone raised their hand. Who has it in production? Not many people raised their hand. And some of that is since there's so many different challenges to have it with good data, to understand the quality, to have control so that it has your data that doesn't get leaked to the world. So that's one thing is the LLM, but then there's this whole other aspect of general AI, which is really apropos, really important to the developer community, which is how can you use AI to improve your whole developer experience, to debug code, to automatically generate different comments. So I'm going to talk about that, and it's called the modern data stack. But first, I'm going to give a little bit about my background. I was introduced having a couple things in sports analytics. I don't know if people are fans of sports. I know one of the big news stories coming here, the number one news, is with chess. I'm a huge chess fan, and I, having won the the Invitational, and Anand being the former world champion, incredible here. And it also is a parallel, I think, to how the world of developer and software development is taking shape. So chess would be boring if only computers played it. If you only have two algorithms playing each other, you push a button in a millisecond, algorithm one beats algorithm two, that would be boring. Super exciting to have humans play each other and the tensions and the creativity. My son is a really well-known junior chess player in America, and so it's fascinating for me to see it's not just using a math formula, it's using skills, emotion, tactics, timing, a little bit of deception, poker face, all of that. And that's why, on one hand, a lot of our world is being automated, but it's still the human element that's going to help win. It's not just writing a program, it's asking the right questions, finding answers, finding the right context. So this slide, I just put one together on my life in terms of sports analytics. In the background is race car driving. I had the fun pleasure before I joined Databricks to work with McLaren in Formula One using machine learning, computer vision, AI to find different use cases to help make the McLaren Formula One race team more effective, to make the car get engineered better. So many different adventures traveling all over the world. And I'm probably most known for that movie Moneyball, which is, I don't know, has anyone heard of Moneyball? Brad Pitt, if you've heard of him. I was not Brad, it was more the Jonah Hill character, partly based on my experiences in real life, taking data and evidence to help do things like which players should we attract, how can a player improve their performance. Very similar to cricket, of course, but one of the worst performing teams in the history of all sports up until the time was the Chicago Cubs. They had never won the World Series since 1908. So it had been over, at that point that we did it, 108 years. So the new owner came in, he was mathematically driven, evidence driven, and he hired me as his first full-time hire out of two to try to help transform their old school way into more data-driven. How do you select players? How do you improve performance? How do you make more money? How do you improve your marketing? Long story short, although I don't want to take any credit, it was truly a team effort. They ended up winning the world championship, which to me was very meaningful for the fan base. You didn't, thank you. It was like generations. You never saw them. Your parents were born, they passed away, they never saw it. Your grandparents passed away, they never saw it. So really meaningful. And that number 44 player, Anthony Rizzo, in addition to using numbers, I was also, it's called a scout, looked at them as a person to see how they would perform. But the moment the ball touched his glove, like that was the final out, and that's when that happened. So curious if anyone knows this gentleman here Travis Kelce. Has anyone here heard his name? So I know he's big in American football. Does anyone know who his girlfriend is? People have heard her. Taylor Swift. Anyone heard of her? So anyway, I do all sorts of fun things. I do like interviews. Had my own podcast and shows. So I interviewed him. He won the Super Bowl on what his thoughts of data and AI were, and how he, like this tough football player, uses analytics to help him. And yeah, it helps him anticipate what the opponent might do, what human elements there are. And that video went viral since Super Bowl champion talking data, AI, sensors, connected, camera-based. And my daughter, she's 20 years old. She goes, "Dad, do you understand how important this person is and Taylor Swift is?" So I thought that was super fun. Shaquille O'Neal had a lot of fun. And then speaking of the Russian prison, I'm the president of the investigation into the fate of this missing humanitarian named Raoul Wallenberg, who rescued hundreds of thousands of Hungarian Jewish people during the Holocaust, but disappeared, was arrested by the Soviets with many eyewitnesses, not knowing what happened. So I'm one of the few people who have gotten access to the Soviet prisons to help identify at first him, but when we got there, identifying many other missing people from all over the world that went into that prison system. So that's a little bit about me. If there's time, I'm around. I love connecting on LinkedIn. I'll share my story on this conference, but if you want to hear more stories, just let me know. Databricks is where I'm at. Joined them about a year and a half ago as what's called an evangelist. It's a funny name, but it's a newish term in technology. Someone who helps speak at conferences like this and try to bring understanding, not just of our company, but when I joined something called Lakehouse. And since I joined a year and a half ago, this whole new world opened up of generative AI, which is part of what we do, but not everything what we do. I am very curious. I talked to many people out there. Not everyone has heard of us. Who has heard of Databricks here? Much of you. I should also say we have many hundreds. I think it's over 400 or 500 people in India, and we've grown 80% locally in the last couple of years. But we started, one of the earlier speakers said to develop some of the best software should be done by the developers or the people that use the software. Otherwise you miss, the train not fitting the tunnel and stuff like that. But our founders are like legends, contributors, creators of Apache Spark and ML Flow and Delta Lake. These are open source technology, which blew me away when I joined, since you're talking hundreds of millions of downloads of these open source systems every single year. Like the amount of use is insane to me. But yeah, you'll probably hear more of us in the coming year or so. We're now the fourth largest private software company in the world. People are pressuring us for IPO, going public. I've honestly no idea when that will happen, but it's big not just in technology, but in the financial markets. And so on the agenda, I'll talk about what is the modern data stack, and then talk about how GenAI is being used both to help the development process from end to end, but then also, how can you build your own LLMs or things called RAG, retrieval augmented generation, or fine tuning on your own data using open source or closed source, closed LLMs if you want as well. And try to tell jokes all the time, but everyone pretty much already knows you can't really turn on any tech website without hearing GenAI. And one of the sayings that I like is like AI doesn't take your job, but somebody who knows how to use AI, will probably possibly take your job as well. But what we are truly seeing is every single industry out there is being affected in I think, a very good, positive, disruptive way with AI. Some industries more than others, but every single business going to be affected by it. And so this is like the modern data stack. What does that mean? There's a term called the lakehouse. It's a fun story. It is something that Databricks came up with, but we didn't want to own it. It's like like a phrase that we wanted it to be a whole market, like a database. There's tons of companies in it. We just wanted companies to have this concept where the lakehouse it combines structured data and data warehousing with unstructured data like data lake. So it's a play on the word, data warehouse and data lake house. And huge challenge in that structured data warehousing is like historical logs. What happened in my sales? What were different transactions that happened? What happened in the past? And then forward looking is more machine learning. You want to do predictive analytics. We're not yet in GenAI. We're talking like random forest and linear regression. How do you take information and project into the future? And you got what are we're now called swamps, data swamps. You would have just ungoverned, unstructured data, PDFs, PowerPoints, Word documents, videos now, all kind of dumped in. And the ability to govern both of these is a big challenge. So you can see there's a gap in the middle. Two very different systems, different platforms. And if you've ever done machine learning, the more types of data you have in general, the more accurate or the more relevant your insights are. So Lakehouse kind of blends it all into one environment, and that's called multimodal. That's one of the phrases out there. We have structured and unstructured. And so I put this diagram together. You might have seen this really cute, is that a puppy? The red hat presenter also had a dog with a red hat and went through a little bit more detail. Is it a muffin, a puppy, a dog, a mop? And so AI could be very good with visual recognition. Tons of companies, when you return, I'm sitting next to someone at a car rental. When you return, it takes a photograph and says, are there scratches or not? Or what is the damage? Could be very helpful. Text-based. One company we helped with was the Texas Rangers, which is a baseball team that won the World Series. And they use text to interpret if all these scouts write reports, what is the big deal? What are their thoughts? Are they positive on this player, negative? Is the thoughts getting better or worse? Or it could be medical information or social media. And then geospatial, that graph, there's always been geospatial, like where were my sales? But where AI really helps is when you talk about like where are those over or under? Where were like your stores being overpriced or underpriced? Where is a hospital having too many or too few doctors or nurses? So that's huge. And then the line chart is a very specialized AI challenge, which is called time series. So challenge before there were lake houses is you would have multiple vendors and you would try to do a predictive analytic, and it would be like near impossible to tie structured, unstructured data sources together. So without doing that, you're going to miss out on the complexities of real life. If something happens, if a player is this tall and somebody says they're deceptive and these conditions are met, that's the real case where you have this player is going to be the next Lionel Messi. But if you don't join the data, you're going to miss that complexity. So struggling to bring it all together, you're going to have different machine learning challenges. How do you even account for streaming data as data is coming in real time, like with the McLaren Formula One? How do you handle that? Or you're a video game maker when you want to match two players immediately through streaming data or prevent like kids cursing, saying bad words. How are you going to do that without interpreting streaming data? And then governing it all, huge challenge. So you end up stitching all of these different services together to succeed. So that was the data lakehouse. And then like 2022 came, although there was already some Gen AI back in the day. So you take a lakehouse, then you take generative AI, and it is what is the new modern data stack. It's called the Data Intelligence Platform. And we hope that this will become the next kind of standard out there. In fact, pretty sure it will. And this is where you understand what your data is and you bring best context out from that. And I'm going to give a demo in a moment of what that looks like. So just the Databricks data intelligence platform, kind of going from the bottom up. You have like some open data lake on one of the hyper cloud providers. That's kind of the foundation. And when I said I used to work for Oracle, that was like the old school, the Teradatas of the world. They used to scale to billions or hundreds of billions of records, which was great at the time. We were talking about the Apple II in the last presentation. That was great for a couple megabytes. But now scaling to billions or hundreds of billions no longer cuts it. We're now talking of trillions of records, being able to process it in a pretty reasonable time. So that's the scaler you need. And then this Delta Lake uniform, the underlying technology is a file format called Parquet, but there's also formats like Hudi and Iceberg. So having one ability to have your data reside in any of these formats and still be able to do GenAI on top of it is super important. And then Unity Catalog, this is probably one of the most important aspects of it all, so that you can have data out there. And if you're saying, how much should you charge for my salary, and it's not secure, and it says, this is great, your coworkers are making this many rupees per year, you don't want that to happen. So Unity Catalog is that governance layer. And then Databricks IQ, within the Databricks paradigm, is the ability to get that intelligence out. So let's see. So the actual technologies behind that, and kind of making my way over to get ready for the demo, is Mosaic. If you haven't heard of that, they are like the biggest business LLM company out there. Databricks acquired them for $1.3 billion. Delta Live Tables, you can use intelligence to automate data quality. Like, how do you join tables together? Like fuzzy logic is one use case. Workflows is super important. Back when I was in the Oracle day, Oracle DBAs were like the best job out there. And then they started automating like all the different levers that you could pull. When you provision a database, how can you automatically fail over your database? And now this is happening in your entire development lifecycle. How can you automate some of your development workflow, your machine language workflow, and so on? And then in terms of Databricks SQL, which if you haven't heard of, it's actually the fastest growing data warehouse on the market now, is how can you use intelligence to better make that perform to scale? So I don't know the skill level of people here, or the experience, but there's a blog that I wrote if people are interested to learn more on what are the 4 phases that we see today of developing an LLM. So this is one, connect with me on LinkedIn or Google my name, an LLM. But the very first one is prompt engineering. If anyone has children, or it's where you go to any open website and you could just say, I'm writing an essay on this subject, or here's an article, can you summarize it in 5 bullet points? That's prompt engineering. You are dependent on another LLM that another company made, and it may not be trained on the information. And then there's retrieval augmented generation. Has anyone here done RAG? This is like where 90% of the LLM world is right now. They're on RAG. And this is the process where you're still using somebody else's LLM to process the information, but you're feeding it some of your own data and information. Not always the most. You could say, given these 10, 20, 100 documents, can you please summarize that? Now, out of the box, the challenge with that is if you have medical information or protective information, that goes to ChatGPT or whoever you're using. It's not secure out of the box. So a lot of companies actually can't do that unless they have a system to make it all integrated. Then fine-tuning, which is where companies are now starting to dip their toe in, is like the next level. This is where you can take an existing LLM and then kind of build some context onto it. So for example, in baseball, I use the term deceptive. If you're throwing a pitch and it's deceiving the batter, that's a great thing. But in other worlds, like if somebody is in finance and they're deceptive, they may go to jail. That's a bad thing. So fine tuning enables you to take an LLM someone made and make it react differently to the context of the information you have. And then the next step, which not everyone's doing, very few people are doing, but it will be more and more popular, is just pre-training an entire model. And it's getting more popular since it's getting less and less expensive and more easy. This is where you could take trillions of data points, hundreds of billions of parameters, and make your own LLM. It's the most effective since it knows your data, and it knows the context and the language that you're trying to use. But up until now has been very hard to do. Like ChatGPT cost them tens, hundreds of millions of dollars to develop. But now, as an example, I helped train our own model, and it was pretty good, for about $10,000 to $20,000 of cost for compute. So within 1 year, just think how insane that is. Tens of millions of dollars down to tens of thousands of dollars. You still need a little bit of skill set to make that happen, so it's not commonplace. But the world is making faster, cheaper, better, and you're going to start seeing things like LangChain, where you have different LLMs with different meanings and purposes, all kind of chained together, a model of experts, so to speak. So pros and cons, and all of the different details are in here. You could go to the blog and look for more. I know the print is pretty darn small on this projection, but all different considerations for each step. So the bottom line, as we see that the one of the themes is to do a good machine learning prediction, or to do any AI, you need the data that's good underneath it. It seems to be common sense, but that's been one of the challenges. Is they call it garbage in, garbage out. So that's why this governance is super important. You want to understand what is the lineage of all of your data out there, from the raw files all the way through what models are being interpreted, all the way through how is the LLM being constructed, how's the output. So when you hear of hallucinations or you want to take action, you need to understand what sources are being used. So there's modern governance, something called lineage, from the raw data to your results. Being able to discover your data, share your data, audit and monitor it. So, a couple things you can see on lineage. You don't want a black box. You want to understand, if you're a manager, a non-technical person, how is that all derived? And then the other fun thing is, once you do have an LLM generated, you can now have usage dashboards of the monitoring of it. What questions are being asked? This is if you control it on your own in Unity Catalog, what answers are being given, and so on. So let me switch over now to to show you a quick demo. And with this demo, this is fundamentally how GenAI, if you've ever done a copilot, can help all aspects of software development. So I'm going to walk you through intelligent search. How do you find all of your assets and tables? Instead of just using a keyword, you're able to understand the context. If you type in the word IMDb, that's a database of movies. But if you type in the word film or movies, that's not actually what is written in the table, but it's smart enough to know these are other words, analogies to it. How do you help you write code? I don't know how many people are using that yet. I am, certainly, to help me, what's the phrase to convert from one, casting, one data style to another. And then how do you automatically document your code? And then how do you interact with your data in a natural language? So I have a database that I'm using. It is America-based, although I should say on the flight over, I saw Baja Bali, the beginning. Loved it. It was about 3 hours long. Got to watch the rest in the series. But you're going to kind of walk through it. I'm making this font a little big so you could see through it. So it generally takes a lot of time. I already set up the table. So I have read into it, and you could just see what the data looks like. And so these are the movie names, things like what the rating is, what the genre is, the viewership. So the first thing is the first pain of being either a SQL developer or whatever, Java, Python, is the title. The data is like not very clean. You could see there's a 1 dot, 2 dot. That's not really the title. That's like somehow that got into the data feed. It's kind of dirtyish data. And then in a space and in parentheses, the year. So that year is not literally the title of the movie. So every developer or SQL person has to figure out and write specialized code to kind of strip that. So you either know what you're doing, or you can put in, I'm going to just copy and paste here. So this is like our notebook. And then there's like an add-on for Databricks Assistant. So I'm just going to copy in my language without saying, like typing in, how do I get, basically, how can I strip out this title column? The title name is between a number and the parentheses. And within the parentheses is the release date. So this is not a code I wrote. This is just me typing, what do I want the program to do? Python, R, SQL, things like that. And then I run that, and it comes back with the actual code that I can put back in. It's just a little, yeah, so you could see here's the actual code. And I can just click on the button, puts it back into the notebook, and I can read that. So if you're an expert coder, great. You may have already known it, but like me, I always have to Google, how do I get the data frames out to do the titles? It's a little complex for me, but maybe it would take me 30 minutes to figure it out. But this code assistant did it for me right away. So that's super helpful. And then there's like transformations. So for example, this info column back up here, you can see has general information and descriptions, a lot of information kind of munged all together. And what we want to do is take the stars, which has like the name of the person in the movie concatenated with these pipes, these vertical lines. And again, we can just go, here's the prompt. I'm just saying, please, I'm being polite, extract the director from the cast column in the data frame using a regular expression. Then I said, here's an example of the data. The director is Frank. Here's like the stars with the name separated by commas. And I go ahead and can run that now. And it'll come back with the expression in there with the program for me, being able to extract the director name using regex, which if you're a serious developer, you probably know that, but super handy. If there is a problem, you actually can use a debug as well. And then I pull up, and you can see, by the way, from the result of the code, it no longer has, if I make that bigger, no longer has that 1 dot and the parentheses. So from the younger me talking to me now, I would be blown away by that's actually possible. You're just typing, remove the numbers, remove the parentheses, and it works. It's incredible to see this happening, my opinion. So all of this code was 100% just now generated by the code base. And if I scroll down to the next, you can also do a similar thing by extracting the gross. Gross is a terminology for the actual amount of numbers, money being made. And here the gross used to be a number with the, if I scroll to the right a little bit, with a $sign and M for million. And now it had extracted that out as well. You could use it to diagnose errors, for example. Seeing if things aren't casting appropriately. Then you can save the results back into Unity Catalog. So at the end, you can share with other people, query it, and so on. And then in terms of documentation, you can go ahead, pull out a table, and be able to document. This table, for example, has descriptions of movies from this year to that year, as well as pull up individual individual columns as well. So understanding, the title is the title of the movie, gross is actual numbers made from this year to that year, and that's all AI generated. And then once you do that generation of the data, it gets put into this Unity catalog, so people who are not technical can go ahead and in the header ask for different questions like which director is making the big bucks, as an example. Big bucks is a terminology for most money, and it understands big bucks. Bucks is related to money, money is related to gross, and it can and will come back with the data that you're looking at. So let me just relog in. So I went through there. Yeah, so this is something I came up, show me which customers are likely to churn in the coming year. I think I have to play again. And then you could do things like write an actual function in SQL. So for example, you can use an LLM like to score an opinion. An opinion could be like a Twitter feed or an X feed with a million different opinions. I like this movie, I didn't like that movie. And you can write a SQL function to say, is this review positive or negative on a scale of 1 to 10? Put that value into a new column. So it'll go through each record, use a LLM to score each record, make a rating, and then put it into a new column. So it's using LLM as a function, SQL, Python, R, Scala, etc., which is pretty impressive. And we meaning the industry is just starting in this. So it'll be incredible to see, what creativity, what use cases will be coming. And then in terms of the semantic search, so in the past, let's just say you have 10,000 tables and you have 100,000 columns. You used to have people, their whole job was master data management, writing tediously what each data is. It looks kind of similar. Maybe data is duplicated. Maybe it's siloed. And so you end up with the average company does not know where 90% of their data is. It's not tagged effectively. They're getting more data quicker than they can document it. So this is another area where AI has been incredibly helpful, is that auto documentation. And then when you document it, you can get people to better search for the information that they want. So churn example is a word for a customer, like if it's Air India, one of our customers, if they churn, that means they went, maybe it means they haven't flown in the past 6 months. Maybe it means they haven't flown in a year or 5 years. It really depends on the business to make those definitions, but that's where AI-powered search helps out. You can have a business person say churn means they used to be inactive or they flew once and they haven't flown in the last 12 months. It's really up to the business. So as you develop these rules, you could click on thumbs up or thumbs down, for example. And over time, the more people in your business, the more developers, everyone here is working for the same company, as you give thumbs up, thumbs down, better definitions, kind of learns what the best definitions are. And so it gets smarter, and it's a virtuous cycle where the insights get better and better. So that's something that companies are beginning. But just again, to be able to document and understand tens of thousands of different table columns is super helpful. And then here's like the example I generated of column descriptions, what each table does. And it's really helpful in terms of what the description is. So using AI to help with your software performance, there's workflow. If you're a software developer, if you're a data engineer, you're tasked with getting and loading data and merging data, cleaning data, getting it into different medallions, silver, gold, bronze, gold. But you can use AI now to help you with that process. So of course, if you've ever been like a database administrator, different block sizes affect different performances. You want a different workload. You don't want to scale up something massive if you're just updating one record, but you do want to scale up something massive if you're updating 1 trillion records. So having the knowledge of what type of operation is about to happen is really where AI is also being affecting this data intelligence platform. How you could predict what IO is about to happen, and then scale up or scale down automatically, like all the dials that used to be manually pressed. So workload management, over time, it saves performance, it saves data from being copied back and forth. And then Databricks, one of our biggest, fastest growing areas is serverless. Our Databricks SQL Server warehouse, again, it's the fastest growing in terms of revenue and workloads out there on the market. But now with it being serverless, you can spin up data warehouses really quickly. You don't have to go through the whole operations, which could take minutes, hours, etc., or scale it down. So all of those self-controls are more and more automated. This is a demo that I gave with my own baseball data. I just took screenshots. I promise. I didn't try 5 times and took the screenshot I liked. It was me taking my baseball data, which is every single time there's a pitch, like what was the velocity, did they swing at it or not? And I did not define anything. It just took from the words start speed, end speed. And for me, having watched the game, I know start speed is the pitch velocity, not end speed. But with GenAI, it figured it out on its own, what I was looking for. So now we have companies, you upload the data, plug it into Unity Catalog, and you can just write in plain English which batter, like their hip was too much forward when they started swinging. And it in my opinion, miraculous, but it's really complex math behind the scenes. It's not miracle, like the earlier speaker said. The program's just doing what you asked for it, doesn't know your intent. But it didn't know my intent, but it was pretty brilliant being able to take my baseball data and write a SQL code that would tell me, what was the average pitch speeds by pitch type. And it came. And then I was able to just say, okay, great, make a chart for that. So generating LLMs on this modern data stack, this is something that changes all the time. Every week, every couple weeks, something new is coming out. But what seems to be true is companies that want to make their own LLMs they tend to prefer open source, so they can know as much as they can what's happening behind the scenes. They're trying to figure out which LLM is better than another for their use case. That's one challenge, is there aren't, like with linear regression, there's R squared, which is a number that'll tell you this model is more accurate than that model with this data set. With LLMs, it's still a little bit of a gut feel. People kind of humans voting up or down what's more accurate. There are starting to be some seeing how similar it is to other answers of pre-trained data, but still figuring out, the accuracy, figuring out, is it hallucinating? Is it leaking information? Is what everyone's still looking for. And then LLM ops. If you've heard of ML ops, that's the operationalizing of machine learning. LLM ops is the extension of that. When was a model made? What is the source of data? How many parameters were in it? Who's been accessing it? Who's not been accessing it? Who's been trying to access it that doesn't have permissions? All of that is part of the LLM ops, as well as how can I make an endpoint? Once I've created an LLM, how can I make like an API call into it as easy as possible? So here is an LLM that you don't want to have. This is another blog I just came out. Follow me on LinkedIn, Google my name. You could see the whole thing, but you don't want to have a prompt where an end user says, my phone plan's too expensive. What can you offer me? And the response is, no problem. Your coworker, Nicholas, only made 5 international calls last month. We charged him 20 a month. How does that sound? You don't want that to happen. Let's see if there's other fun ones. Like here's a fun one of a website where you want it to automatically generate descriptions. It might be too small except for the people in the front, but like that hose says, I apologize, but I cannot complete this task. It uses a trademarked brand name, which goes against our policy. That is not the name of the product. Or those chairs. I apologize, I cannot fulfill this request. It violates our OpenAI policy use case. So that's the thing you want to avoid. And that's kind of universal true these days about it. So the one fun thing is DBRX, which is our latest LLM. It's actually the highest, the best performant LLM for now out there in the market, kind of better than Mixtral or Llama or so on. But we have an ability where you can play around with different LLMs and do everything like sentiment analysis or writing JSON. Here's a list of records. Turn this into a JSON code, or the sentiment analysis, or describe some the document, summarize it, answer a question. And you can have like 2 or 3 or 4 different LLMs that you can compare and contrast. Llama, Mixtral, etc., which is a fun thing. Also, one website I've gone to, if you don't have a Databricks account, is you.com. They basically, you go there now. You can go on your phone. It's like a summary of all different LLMs that are out there that you could play around with without having to have like a license for basic usage. So I use that a lot myself when I write speeches or whatever. Give me brainstorming ideas. Tell me famous people from Bangalore, stuff like that. What are the top 5 things? Here's my budget to do in Delhi, and so YOU, and they have the Databricks DBRX in there as well. And to help with that, so Mosaic ML has revolutionized the ability for businesses to make their own LLMs. So you could build, for example, your own RAG. It's called a RAG Studio, extremely easily. If you have programming knowledge, super helpful. If not, you can still point it to what sources of data you have, and it'll help get you along the way. So DBRX, just a little bit about that. It's I lost track of days, probably about 2 weeks old right now, but it's this mixture of experts, which is kind of the newer approach that companies are taking, where you can have multiple like efforts that all kind of draw together, chain together, and pull out the best answer from each of these. So the reason that that's helpful is, number one, is it sometimes is more accurate, but it's definitely more performant. Instead of going through everything, it breaks the data into chunks, it breaks the questions into chunks, and then joins back in at the end. So at the end, you could get your answers much quicker, much less money. A lot of these LLMs these days to create them are pretty time consuming and costly, which is why NVIDIA and AMD, well, NVIDIA is certainly like $1 trillion company since the compute is so much. So that's why we're starting to see these new approaches to generating LLMs. So DBRX, at its base, a pre-trained model. You can kind of interject at any of the checkpoints and kind of follow along from the very beginning, from checkpoint 1, 2, 3, or the final fine-tuned model as well. And performance-wise, all different benchmarks. You can see the symbols of Meta and Mixtral and so on. So really, really good. If you want to try it yourself, different websites. Hugging Face, if you haven't been there, that's kind of like one of the more used platforms out there. LangChain is another where you can kind of get endpoints for certain LLMs that people have made that are offering it up generally for free. So you haven't been to Hugging Face or LangChain, two websites that you definitely should start if you're interested in. And so you can get from both there, our own GitHub, quantified versions as well. And I am probably going to wrap it up. I think this is my last content slide. This is a fun project that I had done not too long ago. Democratization is something that we're all striving to do. As developers, you want to be able to not just collaborate with other developers, but help people who are less skilled in the development of what you are, help kind of raise them up. And like one of the themes we hear is that specialization, non-specialization, like everyone in this room has knowledge that others don't. Every one of you has information I have no idea exists, and vice versa. So the more you can collaborate, the better, like the entity, the company, or civilization, if you take it outside your company, benefits. So data scientists, I worked on a project where I had people screen scrape LinkedIn. We defined a data scientist as if in their job title or their paragraph, if they had the word data science in it. And so that's that small dot. At the time, 100,000 people on LinkedIn. And then we did the word business analyst or data analyst or data engineer, and there were 3 million. So that's 30 times as many people, data analyst as opposed to data scientist. And then Excel was another keyword. There's other people who are end users who don't have Excel in their LinkedIn. Actually, if you use Excel, most people don't even mention it, since it's like, I can drink water type of thing. It doesn't really help you with your career. But people who did put it in, 750 million out there. So, the point is, if you can elevate people who are less technical to do development tasks or to do data science or data workflow engineering, you just helped your company and your business with 30 times the potential value. So with that, I wanted to thank you. It's been an honor talking. Hopefully some of this was helpful. If you follow me on LinkedIn, or I'll be around not just today, but the next couple of days done speaking. So I'm going to be much more in the hanging out mode. I definitely like connecting with people. And I really wish you all the best in your journey. So thank you all very much.